We're going to look at more functions. This lesson deals with exponential functions and their graphs. We're going to look at logarithms in this unit. We'll look at the rules of logarithms. We probably won't be using the graphing calculators as much for the graphing part of it. So that goes away. There we go. I was going to put the whole answers up right away. All right. So in this unit, what we're going to do is we're going to recognize and evaluate an exponential function with base A. We're going to graph them. We're going to use the one-to-one property to solve equations. We're going to recognize, evaluate, and graph exponential functions with base E. Bless you.
Is that on the video?
We're going to, what's E? Who remembers what E is? What is it?
MC squared.
MC squared. Well, that's a different E. Anybody remember E from Algebra 2?
Yes. Isn't it like the same thing as log?
It's
natural log.
Natural log.
It's, okay, the natural log is log base E instead of log base 10. E is just what? 2 point something. I think it's 2.78 something. E is just another irrational number just like pi. E is used with exponential growth, and we find that when we have exponential growth in things out there in the real world, it's growing by exponentially by E's. E's will show a lot. We're going to look at how your interest rate, your interest on your account, if it's continuous interest, you continually add interest, that E is part of that formula, and to figure out how much interest is going to be added to that account. So E is part of, just like pi is part of the circumference of a circle, E is part of exponential growth, whether it's exponential growth, exponential decay, exponential growth by how much your accounts are going to increase by. So we're going to look at that. And then we're going to use exponential functions, here we go, to model real-world examples. So the first thing is evaluate exponential functions with a base of A. So the definition of this exponential function is the exponential function f with a base A is denoted by f of x equals a to the x, where a is greater than 0. Okay, a is bigger than 0, so a is non-negative. It does not equal 1, and it's a real number. Okay? So a is just a number. It's the base. Remember, for an exponent, the base is the number that's being raised to a power. So at this point in the game, we've never had our variable in the exponent. Now our variable is going to be part of the exponent. It's going to be, part of it. Could be x plus 1. We'll get into that. But the base is going to be some number. First example, we have f of x equals 2 raised to the x. So that's our first example. What I would like you to do with your groups right now is I would like you to look at, and we're going to evaluate this. I want you to evaluate this function. Figure out what f of x is for these 5 values, -2, -1, 0, 1, and 2. So you're going to let x be -2. And maybe if I was you, I'd start at the bottom. Let x be +2, let x be 1, then 0, and then work with those negative exponents. You want to join a group somewhere? Here's one. The graph, it's new. They are not. It's not. Yes.
That's the square root of 2.
I was thinking the other day, square root of 2.
The square root of negative, like, no, I'm saying like if you write out that they take the square root.
We've been graphing polynomial functions. What else have you been graphing? rational, quadratic, polynomial.
Yeah.
Now this is the last.
Well, it's whatever. It's zero.
No, we put in
Yeah, we put in for x.
and just switch it forward.
That'd be
Negative one to one.
Forgot about that one. Zero.
Based on Mexico, so he can't speak English. So what he just said.
All right. I'm seeing f of x, when you raise it to the negative 2, I'm seeing a couple different answers here. I'm seeing a couple different answers here. I'm seeing a fourth. I think I saw a negative 4. Anybody have something else? When I said start at the bottom, 2 squared is what? 2 to the first power? 2 to the 0 power? 1. Then we have those negative exponents. Hey, remember, how do we deal with negative exponents?
Make it a fraction.
We make it a fraction. Okay? You cannot take a number, raise it to a negative exponent. It has to be positive first. So negative 4 is not right. You need to bring it down to the denominator. Back in Algebra 1. Bring it to the denominator, make it positive, and 1 squared is what? Or 2 squared is what? 4. So 2 to the negative 2 is 1 over 2 squared. So we get 1/4. 2 to the negative 1, 1/2. 2 to the 0, 2 to the first, 2 squared. So over 0 up 1, over 1 up 2, over 2 up 4. Then we have these negatives, 1/2, 1/4. So what's going to happen on the right side of 0? As I make x bigger and bigger and bigger, what's going to happen to y? It's just going to get bigger and bigger and bigger. Now, does this function have an x-intercept? No. Because what happens when I take x and make it some really huge number, like 1,000,000, 2 raised to the negative 1,000,000. It's going to be 1 over 1 very large number. It's going to be 1 over 1 big. You take 1 and divide it by a really, really super big number, what do you get? I have $1 and I have to divide it among, let's just say, 1,000,000 people. How much is each person going to get? They're not going to even, they won't even get a penny, will they? Okay, so it's going to get really, really super, super, super small. It'll never go to 0. It will never go to 0. So it's going to approach our x-axis, but it will never, ever hit it. And what happens is when you put this into the calculator and do that, it's going to, let's just do it. 1 divided by 2 raised to the 1,000,000. Oops. It tells me here it says I have an error. The calculation exceeds the range of this value. Okay? So it's just very small. And if I take 1 divided by, let's just divide it by 1,000,000. We get 1 e to the negative 6. What's e mean? What's it mean? What'd you say?
2 point something.
The e tells us
Is it the power?
it's the power. It's times 10. So that means I have 1, and I'm going to move the decimal 6 places to the left. Okay? So it's getting smaller and smaller, closer and closer to 0. All right? So there's what our exponential functions are going to look like. Questions here? What do you think 4 to the x is going to look like? It's going to be close to the same thing.
Are we always going to use these numbers?
These are basically the numbers we're going to use, yes. It'll give us our shape, and then we kind of logically think through some things. So 4 to the 0 is 1, 4, 16. In red, I put the y equals 2x. And what can you see here? You can see they both have the same y-intercept, because any number raised to the 0 is going to be 1. But then over here at 1, at 2 to the x, I went up to 2, but at 4 to the x, it's clear up to 4. So the higher that base, what's going to happen to the graph? It's going to grow faster. It's going to grow faster in the positive. What happens over here for the negative exponents?
It's closer to 0.
It's going to get closer to 0 a whole lot faster. All right? Questions there? Everybody done? Now let's look when we have 2 to the negative x. Let's use the same numbers. -2, -1, 0, 1, and 2.
Well, we always use those numbers.
Yep, use those numbers. That gives us that kind of that shape, which way we're going. So for the top one, it's 2 raised to the what power now? It's to the positive 2. So 2 squared is 4. 2 raised to the -1, 2. What's the opposite of 0? It's still 0, so it's still 1. This one now is 2 to the -1, which is 1/2. 2 to the -2 now is 1/4. So we've got -2, 4, -1, 2, 0, 1, 1/2, 2 1/4, so a negative exponent, what's it do to that graph? It reflects over the y-axis. Good job. Questions on that one? Do you think you could graph the next one without making a t-chart? Well, we just had the 4 to the positive x. Was this one. So if it's a negative x, what did we just talk about? What's a negative do to the graph?
It reflects over the y.
Reflects it over the y-axis. So that means it's still going to be at 0, 1. This 1, 2 is now negative 1, 2. And this 1/4 is now over here.
Can we just do the table to make
You can just do the tables if you would like. Negative 2, negative 1, 0, 1, and 2. 16, 4, 1, 1/4, 16. Questions there? Do you guys remember doing this in Algebra 2 at all? Yeah. All right, recall from Algebra 2 that the basic exponential function, a to the x, can have several transformations that affect the graph of the function. What effects would the following transformation have on the function f of x equals 2 to the x? We just talked about making that negative, what the reflection or what the transformation was there. What is this plus 3 outside of it going to do? Moves it up 3. We talked about transformations back in Unit 1 also. So this 3 moves y equals 2 to the x up 3 units. Questions on 5? 6 has how many different transformations there? It has 2. It has that negative. What's the negative going to do? Reflects over what?
X.
X-axis. And then what does this 3 do?
Makes it go up faster.
It's going to make it grow faster. So it's going to be narrower, or it's a vertical shift, vertical stretch, I mean. Think about it, I have that balloon, and I grab a hold of the balloon and I stretch it vertically, it makes it narrower. Questions on 6? How many transformations do I have on 7? Charlie? 1. What is that? it's gonna grow kind of half. So instead of vertically stretching it, we're going to vertically compress it, vertical shrink. Or make it wider. Questions there? So if a number is added or subtracted outside the function, for example, x squared plus 3, 2x plus 3, we move it up or down. What happens if it's part of the function? Grayson?
It'll increase like your exponent.
We'll increase the exponent,
Is it gonna move left?
move
Right.
left. Remember, and I always like to refer back to that quadratic function because that's kind of where we start with. Remember, in the quadratic function, what did this 2 do to the quadratic function? It moved it left. This here, so this is our function. So the 2 was part of that squared. Is that plus 3 up there? So that plus 3 is part of this exponent here. So it is part of what happens here. If you remember, you always shift the opposite. So this is going to be moved. We're going to move it 3 units to the left.
Is that 3? So it doesn't affect your y values whenever you put something in for x?
It will at that point, but what happens is when I move it 3 units to the left. Let's look at this. Let's go back to that first one. Do this one in red. So look what happens. When I let x be negative 3, what's my y? 1. So over here at negative 3, I'm now here at 1. There's a lot of light bulb going on over here. And then when I let x be negative 2, what do I get? It's 2, the first power, which is 2. When I let x be 0, we're 2 to the third, which is 8, so we're clear up here. So, yes, it's this graph shifted over, but you are also correct in the fact that at 0, my graph's going to be it's going to be bigger at that original point. Okay? Questions there? Reese, what happens here on number 9?
It just moves right 1 unit.
Right 1. Sylvia, how many transformations do I have on number 10? How many? 3. Chrissy, you agree with her? No? How many do you see? 4. Okay. So we've got 3. Sylvia, what are your 3? This negative, here's 1.
Another negative x.
Oh, the negative x, okay.
That might be where I was missing it.
There's 1. Where's the second one?
Plus 2.
Plus 2,
Minus 4.
minus 4,
That might be nonsense.
and then this one is the fourth one.
Is that negative and then the 2, are those 2 different ones?
This negative and this negative,
Never.
which takes us to this problem. We have a blank spot. We always have to talk about this somewhere in here. I think we've already talked about it, but let's talk about it again. What's negative 2 to the 4th? Negative 16. Whereas negative 2 raised to the 4th is positive 16. And some of you are going to go, but I put this into my calculator. And I got negative 16. If I put it in parentheses, I get a positive 16. What is being raised in this top one? What's being raised to the 4th power? Just the 2. The negative is not. The calculators, many students will take and put a negative 2 to the 4th, and they'll get a negative 16. They're going, but this is supposed to be positive. Because if you want to raise a negative number to a power, you have to put that whole thing in. If you want the negative to be included in that power, it has to be in parentheses. So for this example here, what is being raised? What is being raised to the negative x plus 2?
2.
Just the 2. So what does the negative out front do to a function? It flips it over the x-axis. See you guys.
Thank you.
You're welcome anytime. Thanks.
Good job.
What does this negative do? Over the y-axis. What does the plus 2 do? Left 2. And the negative 4? Down 4. Questions there? Like this? So at this point, is this hard? No. All of this right here that these reflecting, it's just old stuff, just applied to a new function. That's all. Everyone done. And then here's the E. Recall from Algebra 2. The irrational number E is 2.718281828, so on. It's irrational, it doesn't repeat. It's called the natural base, and the function given by f of x equals e to the x is called the natural exponential function. When we go to ln, natural log. So what do you think is going to happen here? Well, when e is 0, what's my function? Y is 1.
Can you put paper on this?
Yeah. When e is 1, what do we have?
E.
2.7 e, which is 2.71. So go over 1, go up 2 a little bit more. And then negative 1 is going to be 1, approximately 1/3. So it looks pretty close to that 2 to the x, 3 to the x. They all look pretty similar. Questions here? Then we have that one-to-one property we talked about at the beginning. You're probably going, what does one-to-one mean? But what the one-to-one means is that we have two numbers set equal to each other, and the bases are the same, then the exponents have to be equal. Makes sense. If you have 2 to the 4th equals 2 to what power? Well, it has to be 4. So for here, example 12, we have 2 raised to the x minus 4 equals 8 to the x. Well, it's not going to be quite as simple as the bases are same, set the exponents equal, and solve. That's algebra 1 stuff. Here, you're going to have to make the exponents the same. Well, I have 2, base of 2, and a base of 8. Which one can I write? Can I write 8 with the base of 2 or 2 with the base of 8? Well, 8's bigger than 2, so we're probably going to write 2. 8, 2 raised to what power? What does 8 equal? So that's 2 to the 3rd, right? So this isn't going to change. But 8 is 2 to the 3rd power. So I just wrote 8 with a base of 2. And now power to a power, what do I do with those exponents? Multiply them. So we've got 2 to the x minus 4 equals 2 to the 3x. And now the bases are the same, so what has to happen with the exponents? X minus 4 has to equal 3x. So negative 4 equals 2x, so x equals negative 2. Let's check this in our head. Well, what's 8 raised to the negative 2 power? 1 over 64. What's 2 raised to the negative 6th power? What's 2 to the 6th power?
64.
That's 64, because 2 to the 5th is 32. That's 64. It's negative, so it's 1 over 64. Let's skip to number 14 first, and then we'll come back. Because what are we going to do here? We just set the exponents equal to each other. 2x minus 1 equals x plus 5. So x equals 6. That one was easy. sometimes you may have to change both of them.
Mr. Baker said you have to do
You left what?
So you said you have to do it on your desk and change it. It's like caption
Hurry, call me. You don't know my high school jumps.
I don't know if it's whenever I could. I
75.
remember seeing Oh, right here.
Still gotta take my test from yesterday.
It's hard until 2 weeks later when she's fine.
Give me that all.
When did what?
You subtract the x from the 2x. Oh, that's why we were adding 2x and
Subtract x from both sides and then add one. All right, so 13. What base you gonna write these as? 2. So 4 is what? 2 squared. And then 1/2 is 2 to the -1. And then what do we do with the exponents? Distribute. So this is going to be 2x plus 2. And this will be 2 raised to the -x plus 2. And now set those exponents equal. Add the x over. Subtract the 2. And we get 0. So that'd be 4 to the first. This will be 1/2 to the -2, which would be 2 to the 2, which gives us 4, so it works. Questions there?
So for these ones, we're only worried about the exponents.
That's all we're doing, yes, because we have to write, the bases have to be the same first. And then we just set the exponents equal and, okay? All right, and then we have the formulas for compounding interest. When you go to, let's just put it in terms of a savings account, a CD, you go to the bank and you put money in somewhere, and they're going to pay you interest. Interest can be compounded different ways. They can compound annual interest rate compounding per year. They could say quarterly, they could say monthly, they could say daily. All right? So compounding depending on when what happens is if they compound your money quarterly, that means every 3 months they're going to add interest to your savings account. So my savings account has a whole $5 in it. And so every quarter they might add a penny to it. So I put $5 in January. The end of March they give me a penny. Okay? So then what happens from March to June, I get interest not only on the $5, but I also get interest on that penny. Well, it's not going to make much difference, okay? But if you go and put $10,000 into the bank, and let's say, I don't know, let's say your interest at the end of 3 months is $100. So you've got $10,000, then at the end of 3 months, they add another $100 to it. So then you get interest on top of not only the $10,000, but the $100. So you now might get $101 interest. So you understand the difference? Once the interest is added, you get interest on top of interest. So your interest is going to go up. Whereas if it's compounded continuously, what's that mean? that means the interest is just continually compounding. Let's say daily. I'm going to compound it daily. So I get $10,000 January 1st. I may have $1 January 2nd that they add to it. So then on January 3rd, I might get $1.01 added. So you, depending on when the interest is added, is when you start getting interest on top of your interest. If you have a lot of money, that's something you want to look at. My measly $5, $100, however they compound, it's not going to make that much of a difference in the big scheme of things. Compounding continuously is where you're going to earn the most. All right? So in this formula for n compoundings per year, A is the balance in your account. P is the principal, how much you put in that account. R is the interest rate in decimal form. And N is how many times they're going to compound it. For a continuous compounding, right here's that E we talked about. E raised the RT principal. And we're going to, this last example, we're going to look at putting 6% in the bank, compounded quarterly. We're going to figure out how much we're going to have at the end of 4 years. Then we're going to turn around and do the same thing, only it being compounded continuously to show the difference of what it makes. So an account with principal, so we're going to do P is what? P is the principal. What's the 4%? That's your rate, and we're going to make it 0.04. 4 years is the time. Quarterly is N. So how many quarters are there in a year? 4. 12 divided by 4. So N is 4. So your principal is 6,000. Your rate is 0.04, compounded quarterly. All that raised to the N, which is 4, times T, which is 4. Why don't you all get a calculator so you can make sure you know how to put this into your calculator?
Wait, why did you say that?
Why does N equal 4? Because we're compounded quarterly. So there's 12 months in a year. So we're going to put it every quarter, they're going to put interest on. So that's March, June, September, December. Or 12 divided by 4. I'm sorry, quarterly, there's a 4 every 3 months. So quarterly, that's 4.
Was that a T or a plus over where it says N?
End of the T, that's a T.
Okay.
It's end of the T. What's nice about these graphing calculators is I think you can put it in just like it is. Parenthesis, 1 plus 0.04 divided by 4, close your parenthesis, up arrow 16.
Do we need a 6,000?
What's that?
Do we need to put in the 6,000 every time?
I do the 6,000, yep. There's how I put mine in.
Yeah, that's what I got.
I just typed it in as I had it written on my paper. Calculator follows that order of operation. and you should get $7,035.47. Questions there? Now what happens if it's compounded continuously? That's a different formula. Yes, ma'am.
Why did you write it like that? This is the light change.
Why did I do what?
Like write the change like that. The
Oh.
47.
0.47, just a habit.
Oh, but it doesn't have to be like that? Or should I just write it? Oh, okay.
And then for compounded quarterly, A equals PE raised to the RT. So that's 6,000. E rate is 0.04 times 4. Where's the E button on your calculator?
Secondary division.
It's
second.
Natural log.
use the natural log one. Second natural log. So 6,000. If you use second natural log, it automatically puts that power there, and it's 0.04 times 4.
Where's natural?
Natural log's over on the left, right down here. And I heard someone say, did you get 7,041 and 7 cents?
Yeah, you got it right.
So what's the difference in this case? It's $6 for 4 years. If you have millions of dollars, the difference is going to be a whole lot. So when you start investing, when you guys make your millions, and you start investing them